Let me introduce the power amplifier, 1200 watts for shortwaves and 6 meters bands, with the cooling system based on heat pipes technology. It has 7 bands low pass filter, covers 160 up to 6 meters bands with the optimized 5 or 7 order low pass filters. It is assembled in aluminium frame. I will use the FT897 transceiver as a driver, Bird 43 with element for 2500 watts per element as a power meter, and dummy load, which is quite big, and it is standing below the table. And this is the band switching device. Well, let me switch it on. Initially only one cooling fan is engaged. It had the 2 stages of thermal protection. First, thermal relay will be engaged when the copper spreader plate temperature rise above 50 degrees Celsius. At that time the second cooling fan will be engaged, and the second thermal relay will disconnect the PTT line when a copper plate temperature rise above 80 degrees. Well, let me start on 20 meters band with a power level 90 watts. The internal power meter was calibrated on this band. Push to talk is engaged. I'm transmitting. Well, if I raise the input power up to 100 watts, the output will rise too. Well, anyway, I will set it to 90 watts gain, and we'll show the output power from 6 meters down to 160. First band is 6 meters. It will always stand on PTT mode, and I'm transmitting with 90 watts on 6 meters. Next band will be 10 meters. 10 meters with 90 watts. $1,250. Next band is 15 meters. Same power level indeed. Next will be 20. again 20. Next will be 40 meters. Slightly above 1000 watts. Then I will go to 80 meters band. Power level remains the same. And finally, I will go to 6 meters. Oh, 160, not 6. Well, transmitting here. Power is slightly less, 900 watts. Well, let me return to say 20 meters and perform some telegraphy. Next, memory with the Charlie Whiskey, and I will do some telegraphy. After several minutes, the 50 degrees sensor will be engaged and it will switch on the second cooling fan. I'm going to show this moment, but it takes a time for sure. This is the low pass filter with the capacitors. This is the rear side of amplifier. And this is the moment when the second heating fan was engaged. But I still continue to transmit and show that the temperature will not rise up to 80 degrees. It will stay somewhere between 60 and 70 degrees Celsius. will change the band, say for 40 meters, and continue. Well, let me show the operation of SWR protection system. The operation band now is 7 megacycles or 40 meters. So a 40 meters low pass filter is selected. If I change the driving frequency out of LPF band, say for 20 meters, and will start to transmit, the protection system will be engaged. SWR protection LED is active. Thus, amplifier is protected. To reset to the protection system, I have to switch off the 50 volts and switch it on again. Next step will be return to 40 meters and transmit. All is working. Well, now I disconnect the load from transceiver, from amplifier. Disconnect the connector, leave it free, and we'll start the same telegraphy. Again, SWR protection LED is active. Once again, I have to disconnect a 50 volts power supply from alternative current line. And then I have to connect the dummy load and transmit. All is working. But the current and high power protection levels are set for input power, maximum input power slightly higher than 100 watts. So if I raise the driving power for 100 watts here on 40 meters, it will still operate, but with the power higher than 1200 watts. But better to use it on 90 watts. While I showed you these tests, the temperature becomes less than 50 degrees and the second fan is stopped now. Well, switch off the PTT, and that's all for testing of this power amplifier.